Welcome aviators. Today we go over the second part in the TBM digital tool series. The goal of the series is to share all information regarding the TBM digital tools available, as well as how DAIR uses these tools to better serve you. This is brought to you by the TBM Care and the Analytics team. Did you ever wonder how DAIR is using data coming from your aircraft to troubleshoot? In this presentation, we will cover how the data is collected and how we use it to provide support to the service network and you, the end customer. As discussed in the first presentation, there's different types of data that can be analyzed. The process today is faster with the innovation of the Fastbox, but even earlier model aircraft followed the same path when utilizing data. First, the transmission of all data from the aircraft and processing is completed. Secondly, the analysis of the data and coordination with appropriate parties. Lastly, troubleshooting directive and follow-up. In the interest of having better control over the design aspect of the tools utilized for TBM troubleshooting, TBM Care and Analytics team have developed and is continuing to develop in-house tools such as Power BI reports for troubleshooting on aircraft equipped with Fastbox. We will discuss non-Fastbox aircraft a bit later. Today we cover more than 100 aircraft, more than 30 scenarii covered, which is a huge time savings for our service centers and support team. We have created cases according to specific CAS messages in which we are able to transfer the data to a template created in Microsoft Power BI that allows us to manipulate and display relevant data instantly from the moment the data is received in our servers. Some of our tools are at beta testing level as we work with our service network to optimize and fine-tune these tools based on their feedback and feedback from you, the customer. In case you need help in troubleshooting an issue or the service center, you or the service center may reach us directly at TBM Care. Discussing TBM troubleshooting, it is good to review the way data travels from the aircraft to the support teams. After landing, the Fastbox sends the data to Pratt & Whitney, which then processes the data and sends it to DAIR and CAMP. At this point, TBM Care can access the data in case there's a need to analyze the data and pass on troubleshooting to the appropriate service center or the end customer. Here's a quick overview of the architecture and the data transfer mechanism from aircraft serial number 1216 on forward. Environmental information comes from the gas computer or global air system computer, and all other flight data comes from the Garmin avionics units. This information is fed through an RRANK 429 bus to the Fastbox and in parallel to the L3 LDR or Light Data Recorder, also known as the Flight Data Recorder. We also deal with other types of data being recorded, such as ECTM data, data logs, and trend.dat files found on your top MFD SD card. ECTM data is helpful in troubleshooting any issues with erroneous flight hours or abnormal behavior with avionics in general, as it is the operational record-keeping part of the system, which stores flight hours, cycles, and engine starts. Erroneous ECTM data can mean corruption of the SD card files, or perhaps a misplaced file during handling. Fortunately, from aircraft 1216 forward, do not have to worry about sending trend data, as it is done automatically by the Fastbox. While the system still records data log files, which contains various engine parameters and flight information, this and much more is also recorded by the Fastbox. Exceedance data is stored into the display's internal memory. Once we have received the data, we are then able to apply the tools we have developed. As shown here, we are able to choose an aircraft, serial number, and an appropriate failure warning message, and the relevant parameters will be displayed depending on the flight chosen. Showing in real time the functionality of the system, one may see how quickly we may make an analysis by browsing through the relevant parameters, simply by hovering over a desired time of flight. While some of these tools are still in beta test mode, they have allowed us to become more efficient in our responses to our service centers and operators. So what if you don't have a Fastbox? How do we analyze this data? Well, here we show the architecture of the data transfer mechanism for aircraft without Fastbox from serial number 1105 to 1215. As you can see, the gas computer and the Garmin avionics units still feed the LDR directly, and the same amount of data that is sent to the Fastbox is also stored in the LDR. We may also process this data and apply the same Power BI templates in order to manipulate the data for troubleshooting. If you experience an issue, please keep in mind that only 25 hours of flight data are stored in the unit, so please contact your nearest service center as soon as possible so that the data may be retrieved by maintenance personnel. LDR data is also processed and analyzed as discussed before. Any specific parameter may be chosen and displayed for analysis. Flight data for TBM serial number 434 through 1104 will come directly from data logs. As discussed earlier, the top MFD SD card contains ECTM data logs, and trend.dat files. Data log parameters are useful for troubleshooting as it contains airframe info such as fuel quantity indication, current draw, and OAT to name a few. However, the majority of the parameters are related to engine performance and can help troubleshoot issues during engine start or over temperature, for example. Environmental data for TBMs 434 through 1104 is not continuously recorded and stored, but only available by directly connecting a laptop and using the troubleshooting software. While connected, the software allows for real-time in-flight system monitoring, system faults, and component information. 53 available data parameters under 4 different pages cover the bleed system, the ECS VCS, pressurization, and the global air system controller. This recorded data also allows for troubleshooting of the system faults by analysis, very much in the same manner as previously discussed. Once all the parameters are recorded and shared with technical support, data may be plotted to study the behavior of different components. Specific conditions may be analyzed for more efficient troubleshooting. Lastly, in collaboration with Pratt & Whitney and CAMP, DIAIR is working on a new way to treat exceedances more proactively. Data will be analyzed as it is processed by Pratt & Whitney. Proactive analysis will be done by TBM Care, Pratt & Whitney, and C-First, as well as CAMP. Efficient communication with the customer and service center post-preliminary analysis of incident will be possible. Quicker action may be taken, potentially decreasing downtime. That will do it for this episode of the TBM Digital Tool Series. We hope you learned a lot about how troubleshooting is approached, and as always, should you have any issues or need assistance in troubleshooting, please do not hesitate to contact TBM Care by email or by phone. We hope you enjoyed the presentation, and should you have any questions about this or any other presentation, please do not hesitate to contact us. Blue skies and favorable tailwinds.